In this example, the length in centimeter of 240 koalas are recorded in a table. One koala is chosen at random. So we have a table on the right hand side that shows the ranges and the frequencies for the male and the female. And for the first part, we are asked to find the probability that the koala is a female. So in this scenario, we will take the total for the females. So that by taking the frequencies added all to each other and taking the total, which is the male and the female, that would give us on the top for the 114 divided by 240, and that would give us 19 out of 40. And for part B, we need to find the probability that the koala is less than 80 centimeters. So this we look at mainly the ranges and frequencies above 80 centimeters. So in this scenario, the length being less than 80 centimeters, it will be looking at which is mainly the in this scenario be 4 plus 14 plus 20 plus 15 plus 24 plus 32, and all divided by 240. So in this scenario, we looked at both ranges, the male and the female. That will be equated to 109 divided by the total, which will be 240. And this was our answer for this part. And we also told that the koalas under 72 centimeters long are called juvenile. And we will, for part C, we need to find the probability that the koala is a male between 75 centimeters and 85 centimeters long. So in this scenario, we take both ranges, which is the 75 and 85. So we have, for the male, we have the 24 frequency and 47 being added to each other, all divided by the total of both groups, male and female, which is 240. That would give us 71 divided by 240. Now for part D, we need to estimate the probability that a koala chosen at random is juvenile. State one assumption you have made in making your estimate. So in this scenario, we're told that under 72 centimeter long, they are called juvenile. So we need to take that range. So we use interpolation for the males. So the number of male juvenile koalas is, we take the lowest range. So because we're looking at the range of 65 and 70, which is 4, plus we're looking at the range which is the lower than 72, taken away from the range of 70, and 75 taken from the range of 70, as we needed the 72 is within that range, and both multiplied by the frequency of the second range, which is the 70 to 75, and which is 20. So we simplify these values. That would give us 4 plus 8, and that would give us in total juveniles to be 12 of male koalas. Similar scenario, we look at the female juvenile koalas approximately. So we're looking at the ranges of 14 plus, we're looking at the same range, which is 70 take away 70 divided by 75 take away 70, or multiplied by 15 in terms of frequency for the female. That would give us 14 plus 6, which will equal 20 female juvenile koalas. Now in this scenario, we need to also, the assumption is that the distribution of length of koalas between 70 and 75 centimeters is uniform, and this is the assumption that we made in this question. In this example, the histogram shows the distribution of masses in kilograms of 70 adult cats. For part A, find the probability that a cat chosen at random has a mass more than 5 kilograms. So we will start the first step by looking at weights below 5 kilograms. So we look at mainly in this scenario that we take the probability of lower than 5. So we would have the ranges of 1 by 24. So we're looking at, because we're looking at lower than 5, so we have 1 and the range of 24, which is this one here, and plus 2 multiplied by 4, which is this range here, and all divided by 70, which is the total adult cats. So we have 32 divided by 70, and that will give us 16 over 35. For part B, we need to estimate the probability that a cat chosen at random has a mass less than 6.5 kilograms. So we're looking at almost in between within this range here. So in this scenario, we start with the probability that a cat has a mass greater than 6.5. So we look at that range, and then we look at the lower. So we start with being bigger than 6.5. That will be 3/4 multiplied by 2 multiplied by 4. which is the range that we have here, and then that divided by 70, which will give us 6 over 70, and that will be equated to 3 over 35 for the range of lower than 6.5. And then so for us to look at the higher range will be the probability of higher than 6.5 kilograms. We'd have 1 take away from 3 over 35, which will give us 32 over 35 in terms of the weights being less than 6.5 kilograms. And in this scenario, the estimate we have the fact that we have ignored that the case 6.5 is not a problem in this estimate. We are assuming that the class is continuous when we interpolate, and that the probability of being exactly equal to any individual value is negligible. So this is the explanation that we have for this part, which is the part B of this question. In this example, a class of 30 students, 7 are in the choir, 5 are in the school band, and 2 are in the choir and the band. A student is chosen at random from the class. So first we need to draw the Venn diagram to represent this information. So we start by creating our Venn diagram as shown in this square here, or rectangle here. So we have the 2 ranges. So we have 5 in the school and also 3 out, and there will be 2 in between. So in this scenario we have the ranges of C and B, and also so that will be a total for us to find the region that represents the events. We have in this scenario we take 30 taken from 3 plus 2 and plus 5, so that will give us approximately this range, which is range C. C or B, it will be 20. Now for part B, we need to find the probability that the student is not in the band. So we say so the student not in the band is student not in the band is not B. So in this scenario we say probability of not B. In this scenario we would assume it would be the range of 25 over 30, so they are not in the band. So in this scenario it can be simplified to 5 over 6. Now for double I, we have students, the student is not in the choir or the band. So in this scenario the probability of student not in choir or band, that will be represented in the form of 20 over 30, and that will be equivalent to 2 over 3. So this will be our answer for part double I. In this example, a vet surveys hundreds of her clients. She finds that 25 own dogs, 11 own dogs and fish, 11 own cats and fish, 7 own dogs, cats and fish, 40 own fish, 15 own dogs and cats, 53 own cats. A client is chosen at random. Find the probability that a client for part A owns dogs only. So we start first creating our Venn diagram for dogs. So we have dogs. We also have the range of cats, and we also need to take into account the range of fish. So that's fish and cats here and dogs here. So we would have the assumption of for part A, the probability of owning dog only. So we will take the range by taking how many we add the cats ranges, and that will be divided by the total. So that will give us approximately 0.06, which will be this range here. And we are also for the which is taken in this scenario by dividing the total, the cats ranges divided by the total, and for the cats we have 0.35, so does not own a fish. So we find also the range for the cats, and we also found what would be the value. So the cats is taken from having 0.53, so that's 53 on a cat, and also taken from 0.08 plus 0.07 plus 0.03, which will give us approximately 0.35 cats on. Okay, so that will be our range for the cat. So for the intersect between dogs and cats would be in this scenario 0.0. So that intersection comes from 0.15 taken away from 0.07. So we have 15 cats and dogs, and taken away from the range, which is on cat, dogs and fish. So that will give us all the cats and dogs intersection. So that will give us 0.08, which is cat and dogs. Now we also look at the probability of finding the all fish. So in this scenario, for us to find that, it will be 0.26, and then we also have the intersections or finding dog that does not own a fish for part B. So in this scenario, say P does not own fish, so that will be in this scenario 1 taken away from 0.4, and this will give us 0.6, which will be the range that they do not own fish in this scenario. Now we also need to look at part C, which represents the probability of not owning dogs, cats or fish. No cats, dogs or fish. So in this scenario, that will be approximately 0.11, and this is the range which will be outside all three intersections. And for us to find the intersections between cat, fish and dog, which will be 0.07, and we're also told the intersection between cat and dog, that will be 0.03, and the intersection between dogs and fish, that will be 0.04. So that kind of completes our Venn diagram, and also shows the representation in terms of covering the parts A, B and C, and also explaining each value, how was it obtained, and also if we have any owners that do not own any of the pets. And this will be our answer for this question. In this example, there are 25 students in a certain tutor group at Phillips College. There are 16 students in the tutor group studying German, 14 studying French, and 6 studying both French and German. First, we are asked to draw the Venn diagram to represent this information. So we'll start by drawing the Venn diagram. So F represents French, G represents German. So we have 10 studying we're told that 16 studying German, and we have 6 studying both French and German, and 8, I was told that 8 is studying French only, and 1 is not studying either. So in terms of probability for studying for part B, I, we have for studying French will be 14 over 25, which is the total students. For part double I, we have students that study French and German, so that will be in this scenario 6 over 25. For students that study French but not German, that will be the range of 8 over 25. And for a student that does not study French or German, so they do not study neither languages, that will be 1 over 25. And this will be our answer for this question.